Welcome to the WaStop inline check valve demonstration. The WaStop valve is developed by a company called Wapro, based in Sweden, and was initially developed in the year 2000 by Mats Persson, a local engineer who developed the product to overcome problems that were existing with the products that were on the market at that time, which were flap valves and duckbills. The problems that he discovered with those were that debris got caught up in with them, or they didn't get a completely tight seal which allowed backflow to come back in. And living on the Baltic Sea, although it's not tidal, it is affected by storm surges, and there was backflow coming back up into the stormwater system here, flooding the local properties and people's homes and people's gardens, so he wanted to try and prevent that. So WaStop has been sold since the year 2000 worldwide, protecting people and property from flooding. So how does it work? The WaStop inline check valve stops backflow effectively. As you can see in the demo here, we have water on the downstream side of the valve, and this is simulating a backflow event. So if you have a high river level or lake level or any form of high downstream water level, the valve acts as a plug, stopping that flow from coming back upstream. However, being flexible enough to allow water to flow through from the upstream side, so long as your upstream pressure is higher than your downstream pressure, it will still function in a submerged application. A real WaStop looks like this. This is a very thin stainless steel body WaStop. The thinness of the stainless steel is essential to being able to maintain the extremely low head loss that is exhibited by the WaStop inline check valve. This whole part gets inserted inside your existing pipe, and because it's so thin, it means that you're not creating a clog in your pipe. You're not creating something that is going to increase your head loss greatly. With this very thin stainless steel and a very flexible membrane, it means that you have very low head loss, which is important. You're trying to make sure that you're not attenuating water or stopping water coming through your pipe and out into the sea or wherever you're discharging into, because you're not wanting to create upstream flooding. The WaStop inline check valve also has something called a pulsating flow. Pulsating flow is created by when the valve hits its opening pressure point and it pops open. It's not a cracking pressure that we talk about with WaStop, it's an opening pressure. Difference being, a cracking pressure is something like a flap valve, for example, which opens a little bit and allows a trickle of water to come out. When that occurs, you could potentially get a lot of debris building back upstream. With the WaStop, it builds up some pressure, then it hits that opening pressure point, and then it really flows through, pulsating that water out with a higher velocity, making sure that all the debris that's in that pipe and in the seat of the valve is flushed through. When everything is flushed through, it comes down to what we call the closing pressure point. So it comes down to a point where it's snapped shut. And that last little snapshot is also really important because it means that you're cleaning out the seat of your valve and you're getting all of the debris out. When it's snapped shut, it's completely sealed against backflow. That backflow could be water, or it could be odor, it could be insects and animals, it could be any number of things, but being completely sealed, it stops that backflow. The flexible membrane adapts very well to wave conditions as well and to back pressure. So a standard valve will take 5 meters of back pressure, and the hard membrane of the valve will take 8 meters of back pressure, so 16 feet or 26 feet of back pressure. We also have a conical seal on our valves, which means that when you insert that into your pipe, whether it be a concrete pipe, ductile iron, plastic, clay, any number of pipes out there, the valve will slide into your existing pipe and it will seal somewhere on this conical seal here, which is really good for installation because it just makes things so much easier knowing that the valve will be able to be adapted to a range of different pipe IDs. You can also easily reverse the valve by shifting this conical seal to the other end of the valve, and these fixations also on the other end of the valve here, and you have a reversible valve, which means you can install it either at the inlet or the outlet of a chamber, for example, if you don't have access to the actual outlet. The valve is also able to be used in a vertical application. For example, if you're wanting to drain water off a large surface area such as a port or a dock down into the sea, but you're not wanting wave action to come back up into your stormwater system, for example. And because it's completely sealed against backflow, it also is really good for odor applications. So if you're trying to stop odor transmitting through your system, such as a sewer system, then this is also the perfect product for that. We manufactured the WaStop inline check valve from 75 millimeters in diameter, from 3 inches up to 1.8 meters in diameter, or 72 inches, with larger sizes available on demand as well. The WaStop inline check valve has been used in, I think, 54 countries around the world now, and since the year 2000, so we really know it works. Thank you very much for listening to the demonstration about the WaStop inline check valve, and should you require any more information, please don't hesitate to look at our website, wapro.com, and make contact with us there on our chat if you would like to talk directly with any one of us about the applications that you currently have. Thank you. Bye.